In the previous video, I've talked about how we can use this setup with a long piece of resistor to vary the resistance in between any 2 points on this long resistor, and in this way to adjust the voltage across the 2 points using the idea of a potential divider. And this setup, I've called it a potentiometer, and using this idea we can actually make what we call a variable resistor. So let me redraw this and see how that works. Start with a cell here, and suppose that this is connected to, say, a resistor here. Let's see. So let's say this is a fixed resistor, and then further down, I connect this to this long piece of resistor that I used previously. So this is my long resistor now, and here, suppose that I use perhaps a flexible piece of wire that I can make contact with the long resistor, and that I can slide up and down. So in effect, when the current flows through here, it will go into the long resistor along this point, which I can move around, and then the current will go directly into here. It won't go into that. So current goes here, and then it goes here, and then it goes there. So this means that here, down here, the current will skip this part. Right? The current will skip this part. So this part, there will be no current. And this means that the only resistance the current will see is this bit here. And this means that therefore by sliding this up and down, I can actually adjust how much resistance the current will see. So in that way, this can function as what we call a variable resistor. So let me write down this term here. A variable resistor. Okay, and I can, for example, maybe connect say this point to a wire, and connect say that point to a wire, and the potential difference between these 2 points can therefore be adjusted simply by sliding this up and down. Now, just to see how this might work, let me think of some values to calculate. Let's say that the battery voltage is the cell voltage is 1.5 volts as usual, and suppose that resistance is 10 ohms. Okay. Now suppose that this this long resistance, suppose that this long resistance has a total resistance of 100 ohms. Okay, 100 ohms. Now, if I slide this up and down, the resistance down here, between here and here, can be varied because we know that if I have a long piece of wire, that the resistance of the wire is proportional to the length of the wire, and that's because of the resistivity equation. If you recall this equation, that the resistance of a long wire is related to the resistivity of the material, depending on whether it's copper, iron, or some other metal or conducting material, multiplied by the length of the wire and divided by the area of the wire. So the longer the wire, the bigger the resistance, and they are proportional. So just by sliding this up and down, I can adjust this resistance. But suppose that I move this down until this resistance is let's say 1 ohm. This is 1 ohm. So in effect, the current in this circuit would pass through this 10 ohm resistor, and then it will come down and it will pass through this 1 ohm bit of the long resistor. So let me now try and calculate the voltage across those 2 points. Now, so let's say I call this voltage V. Okay. You know that from what we have learned about potential divider in the last video, that the 1.5 volts from the cell is divided between this resistor and this resistor in the ratio of 10:1. Right? It's divided according to the ratio is the ratio of the resistance. Okay, so if this is 1 ohm, then we can use this ratio to calculate the V. And it's fairly straightforward. If you divide it in the ratio 10:1, so you can think of there are 10 plus 1 parts of the voltage, 10 plus 1 part of the voltage in this ratio. And now might be easier if I write this out more explicitly. So let's say I'll give a name to this voltage as well. Let me call this V1 and let me call this V2. So it's easier if I write this out explicitly. So this is what I'm saying is that V1, the ratio of V1 to V2, okay, V1 to V2 is 10:1. It's just the ratio of the resistances, 10:1. Okay, and the 1.5 volt is divided according to this ratio. So therefore the voltage for V2 would be the 1 divided by 10 plus 1, following this ratio, and multiplied by the overall voltage, which is 1.5 volts. If you carry out this calculation with a calculator, we'll find the exact answer. But for now, I'll just say this is roughly, because 1 is smaller, quite a lot smaller than 10, so I take this to be roughly 10. Okay, so 1.5 divided by 10 is 0.15. So the answer is about 0.15 volts. Okay, so that's when I slide this contact all the way close to the bottom, so that it's just the 1 ohm down here. Now, what if I move this up instead? If I move this up towards the other end, it will get to 100 ohms, right? Let's say I move it all the way to the top, So this time, I slide it up so that I change the voltage here, the resistance here to 100 ohms. Okay, by sliding this contact all the way up. So now, what is the voltage V2 across these 2 points? I would have a new ratio now. If this is 100 ohms, the ratio now is 10 to 100. 10 is to 100. Instead of 10 to 1, I have 10 to 100. 10 to 100 is the same as 1 is to 10. So clearly the ratio is reversed. Okay. And now, if I find V2, using this ratio, the V2 now is the 10 in the ratio. So it would be 10 over 1 plus 10 times 1.5. So once again, we can calculate it accurately, but I'm just going to roughly say, just get a rough answer here to show the point. 10 plus 1 is close to 10, so 10 over 10 is 1, and 1 times 1.5, that gives the rough answer as 1.5 volts. Okay, so just by sliding this contact all the way up, I can change the voltage all the way from a small value, close to 0 or 0.15, all the way up to 1.5 volts. Let's slide this up and down. And this is very useful. Traditionally, in the kind of devices that maybe I think many that we still use today, and many that were used in the past decades. For example, when you want to turn up the volume on your television or your radio, we would turn a knob. Right? These days we have digital control where we just press some button and you see a bar on your screen sliding up and down. But there are still many devices around where we have to turn a knob to turn up the volume, for example, or to turn a knob and turn up the lighting on the ceiling. So many of these are often made from a device that looks just like that. It's really cheap to make, just a very simple device. But how does this thing? So just for fun, let's have a look at how this sliding thing along a rod, how does it turn? How can people turn it into a knob for you to turn? You might imagine that if I connect these 2 points to, say, a loudspeaker, okay, I can buy, or maybe a light, I can by varying this resistor make the sound or light stronger or weaker. But how does this thing turn into a knob? Well, let me try to draw this. What they actually do is that they take this long piece of resistor and bend it into maybe something like a semicircle, or a little bit more than semi. Or C shape. And then they take, at the center, they put a knob. And from the knob to this C-shaped resistor now, there would be maybe a short piece of rod that touches the resistor. So when you turn the knob, this rod can rotate around and touch different parts of the resistor. So I think you might start to see the idea now. So what about the rest of the circuit? They are just the same. I would just add those in now. Say I would have this 10 ohm resistor from there, which would connect to here. Okay, and that goes to my battery of 1.5 volts. And this now goes down to here. Okay, so this is my 1.5 volt battery. That's my 10 ohm resistor from up there. And this rod, the rod that was straight, the 100 ohm rod, is now bent into this C-shaped thing. So that's my 100 ohm rod that got bent. Okay, and these 2 points where I take the voltage out to connect to my loudspeaker or my lights would be let's see, that's the point of contact, isn't it, which is here. So I should connect to here, and I should connect that to maybe here. So this will give my voltage V2. So now all I need is to have a bigger knob that attached to this small knob, and when I turn my knob and rotate this left and right, that would change the resistance. Okay, no, wait a minute, I'm not doing this right. This wire should connect directly to the point that slides. Now I shouldn't be connecting it to this end, because this end is that end, and that's not going to change the resistance. So that part is wrong. I should connect to here. So let me try and redraw this. I can. Okay, this wire here should maybe just connect it to here. Should connect to here. Okay, so the current, let's follow this carefully. The current would flow from there to here. Okay, and it will flow into here, and it will flow along here. Let's say along here. Okay, so no current would flow there. So this bit where there's no current, I'll just draw this, would be this bit. So this is the bit where there is no current. Okay, so the current just flow along here. So as you slide the knob, as you rotate the knob, okay, you will change the length of this bit where current flows. So when the current comes down here, it will just flow to here. So if I rotate the knob, say anti-clockwise, this point of contact would come down here, and then there will be less distance for the current to travel, and therefore less resistance. So in this way, just by rotating the knob, we can adjust the length of the bit where current flows through, and therefore change the resistance. And because of this potential divider idea, and that would change the voltage coming out from these 2 points, and then this 2 point can then be used as like a voltage supply and connects to either your lights if you want to adjust its brightness, or to a loudspeaker if this is used in, say, a radio or a television.